Mode from CSC478, going over my final project with you. I wanted to do something that would examine employees or customers of a company. Ideally, wanted to look at my own customers that visit our company's website, but instead found a data set on Kaggle that dealt with employee attrition, whether an employee would leave or not. So I decided to take a look at that and run prediction and clustering models on it. The data was about 15,000 rows and had 10 attributes. So I ran the standard descriptions of the data, saw it was kind of an interesting distribution, saw attributes like employee satisfaction level, how many monthly hours they work, whether they were involved in a work accident, whether their salary was high, medium, low. And I was kind of searching for patterns as I visualized each of these attributes. Not a lot of employees work on a large number of projects. Majority of them haven't been in a work accident. Majority of them haven't left. Only about 4,000 of the 15,000 have. And most of them have been promoted in the past few years. So the first prediction task I attempted was using k-nearest neighbors. I did this after looking at some correlation relationships that I saw, plotting them using different color schemes to visualize crosstabs. So yeah, use k-nearest neighbors. Tried a k of 5. That's kind of what we were taught in class to start out with, and ran that and got some really strong prediction results. Off of a k of 5, saw a 99% accuracy for predicting that an employee would stay, and an 87% one for whether an employee would leave or not. So overall, 96% accuracy, which was really strong. You see a confusion matrix there. I decided to experiment with different values of k to see if ones would do better or worse. And so I ran a for loop from 1 to 20 on those values, and again got really strong values across the board. I saw a dip around with higher values, but in general saw predictions for whether an employee would leave around 88%, which was great. I compared that against a naive Bayes classifier and didn't get as accurate of scores on the training data, 66%, on the test data, 65%. So I kind of tossed that out as another classification method and dug more into k-nearest neighbors. I tried cross-validating the data using 5-fold cross-validation with the KNN model and got the same result, about 98%, so just as strong as the my original KNN model. I also wanted to take a look and see if we could notice any patterns by clustering the employee data. Maybe there's employees that are high earners that work long hours and have left, or there's ones that do the opposite, don't work a lot of hours and don't have a lot of projects and they're bored. So I was looking for that kind of relationship. I tried clustering into sets of 2, 5, and 10. 5 turned out to be the most with the highest homogeneity and completeness scores. You see that down here they had a 21% completeness and 57% homogeneity score, and that was kind of discouraging, especially the completeness score. Looking for patterns in that, I saw out of the 5 clusters that there was kind of a separation of employee satisfaction level. You had one group at 64%, and at the other end you had one at 39%. So that was kind of a drop off. And I saw another one that 39% looked like they had been involved in a work accident or had not been involved in a work accident, whereas the other groups had. But not a lot of variance between other attributes in these clusters. And I thought I might see that at a 2 cluster. Maybe that would isolate that attrition variable, and that did not. It got even worse for clustering, 1%. and even worse for 10%. So clustering was a little more difficult with this assignment, but I was really encouraged by my k-nearest neighbors results and will apply them in the future. Thanks for the opportunity to learn more about machine learning in this class. I appreciate it and valued it. Thanks.